All right, today we are learning sigma notation. So sigma notation is an interesting thing, and you'll enjoy it so much. What's the formula for the nth term of the following sequence? So take a second and see if you remember how to do this for your arithmetic and geometric sequences. All right, so hopefully you got, this one was arithmetic because it went up by 3 every time. It has a common difference. Just put A1 and D into the arithmetic formula and solve. This one is geometric. The common ratio is -2. A1 is 3, and you just plug it into the geometric formula for finding the first term. All right, this is your sigma notation. Sigma is this sigma. It's actually capital sigma. Lowercase sigma actually represents standard deviation. Interesting. So what the deal is, the bottom number tells you where to start, and the top one tells you where to end. So this is technically a sequence, but then the sigma tells you to add them up. So you find all the values in the sequence from whatever this one tells you here. So when k is 1, we're going to plug in 1 for k. So that would be 3. When k is 2, and then we go up, and we keep going up by 1 until we get to 5. So 2 would be 2 squared plus 2, so 6, 3, etc. Let me just do it really quick. And 4, 16 plus 2, and 5. 25 plus 2. So that's great, no, but that's the sequence. So this is the difference now. This is a sequence, 3, 6, 11, 18, 27. A series, and this is where we are now, we're doing a series. That's when you add up all the elements of a sequence. So we simply have to add all of these numbers up together. When we do that, we get 65. So this notation here means figure out each element of the sequence, starting at 1, going to 5, and then add them all up. Okay, so this one right here, sometimes it's not straight numbers. Sometimes you've got to do letters too. So here it has an X, it's got I. Now in this case, they're telling you I is our increment. It's not I as an a complex number. So this is an alternative to what I can be, but they'll always tell you what it is. Okay, I is 2, so this would be 2 squared x to the 2. So it would be 4x squared. I equals 3, so this would be 3 squared, etc. So take a second and just finish this. Right, this is each element of the sequence. Now to do the series, we have to add them all up, and none of these are like terms, so it's just 16x to the 4th plus 9x cubed plus 4x squared. That's all you can do. So we can do these in the calculator. You can't do it if you've got an x. It won't do that for you. But if it's just straight numbers like this one is here, like our first one, you can put these in your calculator, and we'll go over that a bit more clearly in class. But these are the things that you do. You hit second stat math 5, and that's going to give you sum. That's going to add it all up for you in the end. And then second stat ops 5, that's going to do your sequence. And then you have to put specific things in those spots that they tell you. And you can see what that is. If you leave off the sum, interesting things happen, and we'll show you that later. All right, so expand these and state the sum. So take a minute and try to do that. If you can figure out how to do it in your calculator, that's great. If not, take a second and do this yourself. All right, to do this one, you expand these out. This is your expanding, -9, -5, -1, -3. You add these up, and that's the sum. So that's the A and the B. Expanding here, 4, 8, 16, 32. Add these up, and you get 60. All right, there may come a time where you'll have to write your own sigma notation, and this is just the basic rules for it. You determine the geometric or arithmetic, whether it's geometric or arithmetic. Write the explicit formula like we just did in the beginning with the review, and find the number of terms what is the last term. It will always look like this. This is always your first, and we always start at 1. Now, when you are asked to evaluate sigma, they might start it wherever you want, but you're creating your own. We start at 1. Then that's the very last term number, and then this is our explicit formula. Okay? So just a basic example of this, just doing very simple, straightforward ones. All right, we have our sigma. This is what we need to write. We know we're going to start it out at 1. And our first term, you know, we can do all this. Now what we have to do is we have to figure out the explicit formula. But we also know this number up here. This is the first term. This is second, third, fourth, fifth, and sixth. I don't know why there it goes. So this number up here would be 6. Okay, it's the term number, not the value. So remember that, it's always the term number. So finding the explicit formula, well, this is an arithmetic. It's going up by 6 every time. So since it's going up by 6, we know our A1, the common difference is 6. So there's 4. Our explicit formula is first term plus n minus 1 times the common difference. So 4 plus 6n minus 6, so it's 6n, that's annoying me, 6n minus 2. So we just put 6n minus 2 here, and that represents that. Pretty exciting. Have a wonderful day.